This part of the video is about solving equations numerically, and for our classroom project we'll be doing this more than solving equations exactly algebraically. So this is going to be something actually very useful throughout the semester. So the two commands I know, mathematical command I know about this task is this nsolve and find roots. I don't exactly know how they do this nsolve, but I read about it as a find root command using Newton's method. And it works really fast, and this nsolve is sometimes convenient too. It's a numerical solve. So nsolve case, instead of the syntax code is exactly the same as solve command. It's just you put n in there, and then it's going to find the numerical solution. So I recorded data. Again, these solutions, output of this solution command, solve command, or find root command, they're all in the form of substitution rule. So here as I'm showing, so if you define it this way, this nsolve is going to be the two sets of solution. The first solution given in substitution form, x is substituted with this value, and that y for that value, and z for that value. The second set of solution, and so on. So we have two substitution set in here. So this bracket 1 and this one picks up each of the solutions. So if you evaluate some arbitrary formula which was defined earlier, and with this substitution rule syntax, and it's going to evaluate it, such as this one. So let me show you what the formula 5 was, and then you can try yourself and see if you get the same answer. This was from earlier sections. The formula 2 and 3 and 4 was given by these formulas. The formula 5 was given by this trigonometric value. So we're back to that. So if you copy down those formula 2, 3, 4, and if you use formula 5, and then you're supposed to get these numbers. Next command, I personally use it a lot, is this find root. You have a slightly better control, but it requires to visualize the situation. For example, if you want to solve this formula 6 set to 0, if you want to find the 0 of this polynomial, and you can use nsolve, but if you want to use a find root, you want to visualize it first. So you're going to sketch the graph of this cubic polynomial, which can be done using this plot command, which we reviewed earlier. And then it is like this, and you can see there are 3 real numbers it crosses, and this is the one of the zeros, and another 0, and another 0. So we want to find those. So find root will require something called initial guess. If you want to pick this solution, you have to know about roughly where it is. Let's say that was negative 1.5 is roughly where it's located. So you have to use that initial guess to pinpoint this one in a lot more precision. So here's how you do it. Find root, the formula 6, that was degree 3 polynomial, set equal to 0. And then I was a little bit more specific, 1.8. Actually, I was looking at over here and try to find that point, 1.8. So I put 1.8. That's your initial guess, because we see that's close to that. So if you do that and go through this find root, which is something called Newton's method, then it's going to find this more precise value. And you can probably put some options in there. Use this document center to find out how the option works. To if you want like 100th digits, and then that's how this one behaves. That's how you get more accurate, more digits there of the solution to this equation. Sorry. Again, it's given in substitution rule, not just a number. So if you want to use this number, you actually have to make a substitution. Okay, I realize it in the next part I'm showing this option. So there is this working precision 50 option. So again, W and P is in the capital, in this case sensitive. So if you put 50, it's going to give you 50 correct digits. Now let me show you how to solve a system of equation using the find roots. Again, you have to know kind of roughly where the solution are. So to do that, you have to visualize it. So this is polynomial of two variables, a function of two variables. So to sketch it, you have to use something called a contour plot. In calculus, it's also called implicit plot, but let me introduce that. So this is called contour plot. This is not just the formula. It was some formula set it equal to 1. And this formula 6 is a two variable, and formula 7 a two variable in it. So let me show you that again here. This formula 6 is a two variable and formula 7 is two variable. If you set this one to a number or another two variable function, however you do it, it's an equation involving two variable. This usually defines a curve. The solution set of a formula 6 alone is actually represented by a curve. There are lots of xy, pair of xy values that make this formula 6 exactly 1. There's not just one pair of solutions, there are infinitely many. If you just isolate formula 7 and set it equal to 1, the solution set, the pairs, there are infinitely many, and probably there are only finitely many number of pairs that satisfy both formula 6 equal to 1 and formula 7 equal to 1. And that's what we are looking at. That's the meaning of a system of equation. So here it's visualized by this graph, something called contour plot. We're sketching two graphs, so we have to put this parentheses around it, and these are x and y values that determine the size of this window. So let me show you the picture. So if you sketch the both curve together, one correspond to formula 6 and the other one correspond to formula 7, the point that satisfied both equations are here and there, and there's another point there, another point there. So we know there's 4 points. And this is just a picture in between -2 and +2, and then here and there, so we never know exactly what's going on outside this window. But if we're just looking at this window and this is all we see. Again, this is not rigorous. Maybe there's a tiny thing that is not showing, and it is, you believe this machine is good enough to capture everything. Actually, there are examples I've encountered that Mathematica wasn't able to pick up something going on in here. So that's why we're doing Mathematica in a slightly different way. But this is still a great tool. So let's assume that these 4 points are the only thing that we want to find the precise coordinate of this one. And then you're going to use find roots command. So if you look at this x coordinate 1 over there, and over there, if you look at this point, it looks like just about 0.5 or 0.4 y coordinate. So I was looking for that point, roughly, got a rough idea of what the x coordinate, y coordinate of that point is. So that's why I put it up there. Now it's going to be find root of two equations. So I put this equation with double equal symbol in there, and x is going to be close to 1 and y is going to be close to 0.5. That's initial guess I chose. And then you solve for it, and the solution will be recorded in substitution form to IP1. So here's we usually want this solution in the following form: x comma y. So because this formula 6 and formula 7 has x and y in it, so if you put x comma y and substitute whatever the substitution rule is showing there, and its x is going to be substituted with that substitution rule there, IP1, which is a substitution rule. That's how the solutions of a Mathematica command puts out if it is a find root and solve or solve. So that becomes an actual point and not a substitution rule. So here's a showing that if the first line without semicolon, then it is showing what it did. So there's only one pair of solutions, so it's find root only usually find just one pair, so it spits out like this. If it is an and solve, it's going to have additional parentheses around it, because it's trying to find everything. Even though if there is one solution, it's going to show in another label of list. So if you have this x comma y, and when x and y replaced by the substitution rule, which is tagged here, then this whole point 1 will be this actual point that you want to see. This document is found in our course website, and you can try and all the other 4 points, but let me show you how to do the second point. I'm choosing -1, 0. Here's a picture again. -1 is here, and 0 is roughly there. So I kind of see that there's one point close to -1 comma 0. So if you choose that initial guess and do the same thing, you can see actually -1 comma 0 is the exact solution. You can probably verify by hand, going back to the equation, that it has the solutions. Again, those were two commands, nsolve and find roots, and they're very, very useful. Thanks.